Hey guys, and welcome back to another YouTube video. So, in the last videos, I told you that I was working towards text classification, and I was trying my best to get some neural network done. I wasn't finding some good data on it. I was trying to do sentiment analysis, and so I wasn't really finding any good data to play around. So I'm using this. So this entire neural network that you are seeing is taken from TensorFlow, the TensorFlow YouTube channel. So shout outs to them. Um, this neural network was done in their zero to hero neural network course, so that's why. So today we are gonna be making a text classification neural network that will make an Irish song. So you can see this is the entire neural network. So first, these are just the imports that we have made, very standard, nothing new. So we are using TensorFlow as always, because that's the module I'm most uh, familiar with. Then this is the link to the data. So it's stored in the Google Cloud. So I'm just gonna run this code block also. Then what I've done over here is created a tokenizer. So what a tokenizer is it will take the words and it will convert each and every word to a letter. So this is how a neural network with text classification works, is that it will take the words and it will convert each of the word to map it to a single number like 1. So if there is a sentence this is a good day, let's just say this is a sunny day, this is a rainy day, then this is will be mapped to like 1 2 3. And if we make sunny as 4 and day is 5 and we make rainy as 6, so it will be something like 1 2 3 4 5 and 1 2 3 6 5, and it will be like that. So you can see that there will be some differences in the sentences. So that's what a tokenizer does. And it's very simple to create a tokenizer. In TensorFlow, we just type out any variable name is equals to a tokenizer with a capital T and the parentheses. Then we have just simply opened it up from a temp directory and then and read it. Now we have just split the data with a backslash n, so there will be so we will be getting what do you say, since what a backslash n does is will go to a new line. So all of the data that we have collected will then go to a new line. Then what this tokenizer.fit on corpus does is it will basically take the tokenizer and it will apply it to the corpus of the words that we have shown it. Now the reason why we split it to a lower is because, so all of the things with the letters, like if the capital letters we just split to, we turn to a lower letter, so everything remains consistent. Then we have done it like if the length of tokenizer word index plus 1, so the total number of words, that's the total number of words. And then we have just printed out the total words and so we can see there are 2690 total words. Now what we have done over here is we have just done some data processing. So what we have done is, for every line in the entire corpus, what we have done is taken the tokenizer and put in the text to sequences function on it. So what the text to sequences function will do is what I just told, like it will map it. And then for index and range for the token list, we have just put in every single sequence into the input sequences. Then what we have done over here is we have just converted all of this to a numpy array, so it's easier and faster processing. And you can see on printing certain word indexes, you can see what the word indexes are. So I'm just gonna print some of these. So you can see how this is. Now we have created the neural network over here. So this neural network is not a CNN, it's called an RNN, or a recurrent neural network. A recurrent neural network does not use convolutions, it uses stuff like embedding layers and LSTM layers. What an embedding layer does is, let's just say the word good and bad. So if we say something like um, I love my dog and I hate my dog. So the sentences, if we just use it with the numbers, they are pretty similar, but indeed they are completely different sentences, because a good and bad is opposite. So we cannot really classify those sentences as similar, because that will be actually incorrect. So what we actually do is, uh, instead of adding convolutions to detect features, we add an embedding layer. What an embedding layer will do is, it will like take the word good and bad, and it will put it on a line, and good will be placed at, like, let's just on the right hand side of the line, and bad will be placed on the left hand side of the line. So they're completely opposite words. But if the word is like okay, then it will be placed at a 90-degree angle on the line, as because it's not bad but it's also not good. So it's neutral. But if we have a word like let's just say um, something like wow, if we or wow or something like that, like it's more on the surprised side, but surprise is like usually in the good side. So that's why we put it on the angle that is closer to good. That's what an embedding layer does. And LSTM, basically what it does, it's it creates a memory, so it will keep on remembering all the sentences, and it will then we put it in a bi-directional thing, so it will keep on remembering the words of the sentence from first to last and last to first. So if I just run this code block, you can see we have 10 epochs and a single verbose. And over here what we have done is just plot everything, and this is the actual cool thing. So what we have done is provided something called a seed text. So the seed text is basically the text on which we will be after which we are going to be putting in the different words. So the next words are 100, and then what this is for underscore in range next words, is we are basically now converting all of these words or the seed text to the sequence, and then we are just doing what we had done up top over here, but we are doing it to the seed text that we have provided it, and then we have just taken an output word. And for every single word index in the tokenizer word index items, so the things that we have created up top, so we are just taking in the word and we are just printing it out to the screen. It's very simple. So if I'm just gonna take this and run each and every of this code block, you can see that the accuracy is like increased, and it's like at a 70% accuracy by the 8th epoch. So we have reached like a 73% accuracy. Now I think this is becoming something like a problem. It's okay. So we have this. So I've got a bad feeling about this. One night, so on a man who my eyes break, love. Okay. So obviously this neural network is not very accurate. So you can see it says like love, but it can say love and letter. So that's obviously like what should come after love or anything like that. And this young man died. I love sense love in his eyes. Love from my cozy nest. I has love. So you can see. So it actually made like a little Irish song. Obviously, it's not very good. Obviously, but if you actually play around with this neural network, if you add, now the cool thing is, if I just take this bidirectional LSTM and if I just copy it up, I just paste it over here. Now you will see that these embedding layers that we have created, which do all of these things. Okay, apparently this is an error. Okay, obviously we need to be adding an embedding layer. so we can't really stack up these bidirectional just like that. So what these embedding layers usually take off a lot of training parameters. You can see there are 377 training parameters in a single epoch. So it's common sense that there are a ton of training parameters, and that's a like, so if you don't have a lot of time to process your neural network, then it is not the best choice to keep on stacking embedding layers, because they really take up a ton of training parameters. So it's not a really great choice to just keep on stacking embedding layers if you do not have a lot of time to process your data. But nevertheless, if you have a decent amount of time, embedding layers are the way to go. But you need to sacrifice the amount of time for, if you want to make a good neural network, obviously. You can obviously increase the number of epochs and do all of this. Now you can see sometimes also these embedding layers are not the best choice. You can see on the fifth epoch we are just running a 6% accuracy even after we have added a bidirectional LSTM on the embedding layer. Now, it's not always you are gonna be getting those cool high accuracies. Text classification in some cases is really difficult to get correct. So you obviously are going to be playing around with which layers you want and when you want them. Also, the thing is there is a learning rate on this, and so that's why it's very slow. We can also decrease or increase the learning rate to make all of this much better. So let me actually tell you. So if I just change this learning rate to something like 0.57, I'm just going to take that. So you will see what will happen. So I'm just going to let this run real quick. Now that's the thing. Everything depends on how you are tuning your hyperparameters. You can also use Keras tuner and use it to actually tell you what are the best layers and how many layers you want to go with your network. But the best way is to play around with yourself, because Keras tuner is like, it will provide you a decent amount of information, but it's good that you yourself play around with this. Now you can see on increasing the learning rate, the loss is just nothing. But you can see even the accuracy is just not really there. We are running on a 0% accuracy, which is not what we want. So let's specify a lower learning rate. You will have a loss, but you also will have an accuracy. Just the way to increase the accuracy in this type of like a text classification, the best way is just put more epochs and only add layers when you really want to add them. Don't just keep on stacking layers, because it's usually not the best thing. Because let me actually tell you something cool. So if I just add just a code block over and just type out model dot summary, I'm just gonna run this code block over here. We will just wait for a second. You will see actually that the on getting the summary of the model, you will see the amount of training parameters on comparison with the layers will be very high. So you really need to sacrifice some processing time for a good neural network. So let me show you. So we have run the 10 things. So you can see it is sequential 4. Okay. So on getting an embedding 6 and an embedding layer, you can see the number of training parameters are so many. So you can see there are 269,000 training parameters, which is certainly a lot when you are having a look at this. So having so many training parameters, you can see. So even the bidirectional has so many training parameters. The dense obviously has a lot. So that's why. Now that's so we have now finally done this. We have uh, now if I just change this to something like uh, this is a nice experience. change this speed. So I'm just gonna run this again. So this is a nice experience, young lady. I'll go quoting and buy. And gone and child and gone, half of immortal. Okay, so it's spire of bright eyes today and gone again. So you can see, like, at some areas you can see uh, that it's kind of getting like a good thing, but it's not very good at actually making an Irish poem. So if you certainly want to make this, you can just put in 100 or 1,000 epochs, train it over the night, and by the time it will be morning, you will run your network and it will be predicting like wonderful songs, actual things that you can actually sell in the market. So text classification, a lot of things that you can do with it. This is something like sentiment analysis. There is stuff like we can do with the CSV files, but I usually do not deal with a lot of times with the CSV files because like you can also do stuff like stock market price prediction. It's certainly a bit more difficult and stuff, but you can also try and do that. So that's it for this video. I will try and put up even more text classification RNN videos in the future. So that's it for today, guys. I hope you enjoyed the video. If you did, like and subscribe, and I will see you in another YouTube video.